Welcome to the Build at Scale Lab. Today we would be diving into accurate object positioning on Omniverse, which is a crucial step towards building a functional digital twin. Our goal is to set up Theo, a standard cobot arm, and his environment precisely and accurately in the exact same position in a virtual environment, just as it is in real life. In order to do so, we would be using the NVIDIA Omniverse Snap and Pivot tool, and this can help you make sure your environment is perfectly set up for you to start off on your digital twin simulation. So let's get started. So let's take a closer look at Theo's environment. The cobot arm is mounted on a base, and Theo is going to be performing a very simple pick and place task or a puzzle. So he is going to be picking up that green block from there and placing it on that plate. So the elements that we need to position on the Omniverse environment are the robotic base, the table, and the puzzle on the table. So in order to get started with actually measuring things, we need to first look at where the objects are placed in the extended environment. So here I can see that the robot base and the arm is placed very close to this wall, and so is its environment. I would be measuring everything with reference to this wall over here. So the ideal way to measure things would be to have a LiDAR scanner and get accurate point cloud data and accurate coordinates. But if you're trying to do things on a budget, then all you need are good measuring tools and a pencil. So another tip to measure is to always choose one reference point for every object and measure everything with respect to that particular point. So for this robot base, I would be choosing this point over here, which is the edge of the base closest to the wall as my reference point, and I would be measuring everything from that. The reason why this is important is that when you take these measurements into the 3D model, and you would be placing the pivot tool exactly at this particular position and move things accordingly. So once you're done with your measurements, a good practice would be to note them down on a piece of paper or on a whiteboard like I've done over here. This is the top view or the plan view of the environment. So you can see Theo's base over here with respect to the table and the wall and the puzzle too. As you can see, I've taken all the measurements that I need. So our most important measurement is this, which is the distance of our reference point from our reference element, the wall. I've also taken this other measurement for Theo, which is the measurement from this point over here, which is the other end of the base to the wall. Then these are the measurements of the table and the measurements of the puzzle with respect to the wall. And I know that the cube is like 5 centimeters and the entire puzzle itself has a 15 by 15 centimeter dimension. I would say that you can take as many measurements as you want, but ideally you could just take the basic measurements and do all the complicated stuff using some simple math. So for example, I know that Theo's base is tilted at a certain angle, so I'm not going to be measuring the actual angle in real life. All I need are these measurements, and I can use some simple trigonometry to figure out the angle over here. So I know the distances, and I also know the dimensions of Theo's base. So I'm going to use that and find the angle over here. So this is the base environment on Omniverse. As you can see, I have imported the 3D models of Theo, the table, and the puzzle, and I've just placed it in the environment. They are not in the exact positions as they are in real life, so we would be working on positioning them accurately. This is the overall environment of the lab, and I've just focused my camera on this area for better understanding. Let me give you a quick rundown of my workspace. These are my layers on my stage. These are my waypoints for a very quick navigation, so I can just move to wherever I want in this environment using my waypoints. And these are my property panels, so I could use the move and the rotation commands over here, and I can also look at the exact position of the objects, the angle of rotation, and its scale over here. Now let's look into the snap and pivot tool. So the snap tool helps you accurately snap the objects onto another object or surface, and the pivot tool helps you move the object with respect to the pivot point. This pivot point can be changed according to your convenience. Let me show you where these tools are located. So whenever you click on any object or element on Omniverse, you would see a small arrow underneath the 3 axis, and this is where you would find your snap and pivot tool. You can activate or deactivate your snap tool according to your convenience, and in terms of the pivot tool, you can click over here to get a more detailed overview of what the pivot tool actually does. So now that we know how to access the pivot and the snap tool, we would now jump into actually positioning these objects in its exact positions. I'm going to start off by positioning Theo first, and I would eventually get on to the table, the task puzzle. So when you want to position Theo, like I said, always keep the measurements handy. So I have this in an image in another desktop. Now that I have my measurements with me, I would first change the pivot point of Theo, right? Because at the moment, the entire model has a pivot point in the center, but we discussed how we are going to have the pivot point of the model on the right hand side corner of the base. So we're going to work towards making that happen. I'm going to now zoom into this area to position my pivot where I want it to be. So yeah, we discussed that we want the pivot point over here because this is a reference point that we use to measure the distances from the walls, right? So I'm going to now check where the existing pivot point of this particular part of the base is, and I see it somewhere over here, right? So now I check if the selection center is selected. Then I open up my pivot tool and I add pivot. So once I add my pivot, I then I'm able to move my pivot wherever I want it to be. I bring it to its extreme positions. So as you can see now, the pivot is in the cornermost part, but not quite there on that surface, right? So I'm gonna again do a little bit of movement, and now I can see that this pivot is exactly at the point that we use to measure in real life. So this is good. Now that I've picked the exact pivot for this particular part of the base, I want to now set the entire model's pivot to this particular point. So what I'm going to do is I'm going to first zoom out a little and I click on the model. So the pivot of this model is somewhere over here. So I'm going to open up my pivot tool again, and I see that instead of like moving this around, I use this really cool feature called pick source. So I'm going to click on pick source and it'll let me pick the pivot of any object or any element, either in this particular model itself or like any of the other models like the tables or like the floor or the wall, etc. And I can match that pivot to this one. So just check this out. I'm going to pick source and I'm going to click on this particular cuboid, and there you go. You have the entire model's pivot positioned to this particular cuboid's pivot. So now we can move the entire robot model and its base in accordance to this particular point. In order to position this somewhere over here, as it is in real life, I think the easiest way to do it is to first snap this model to this edge and this corner over here. And since we have the measurement of how far along the robot is from this edge, both vertically and horizontally, I think this is a good way to start. Okay, now it's time to activate the snap tool. So I'm just going to click on the snap tool to activate it. But I'm going to make sure that my edge, surface, vertex are options are selected, because we want the model to be snapping to the edge or the surface or the vertex that we want it to snap to, right? So now I'm going to click on the center point and move my model accordingly. So this tends to go haywire, right? The best way to do it is obviously have like a good angle first. So I think I like this angle because I can see both this edge as well as this point over here. So now I'm gonna pull this over here and aha, now I've exactly place this where it's supposed to, meet. Now, in order to move the model accordingly, I'm going to first check my measurements over here. So now I know that the model is 1.562 meters away from this particular point over here. And from once you moved it there, then you can again move it like this by 0.56 meters. I prefer to make most of my movements using the translate option over here. So I think this transform tab itself would be your best friend right now. And one thing I forgot to mention before is always note down your Y value before you move your object to snap somewhere, because as you can see, the model has gone under the base ground level. So I know that my initial y value was minus 0.04095, and now it has changed to 0.2 something, right? So I'm just gonna change it back to 0.04095. Okay. uh Now that I've done this, you can see now it's back to ground level. Now let's change the x-axis translation value to move it to where it exactly should be. So that means I would be adding 1.562 to this current x value. So 2.20786 plus 1.562 is 3.76 986. So I'm being very, very specific here to up to like 5 decimal points, but that's because I want it to be as accurate and precise as possible. It's up to you how precise you want it. So now I'm going to move the model ever so slightly to see where this model has been placed. Let's work on the z-axis now. So the current value is minus 4.9 something, and I know I need to be adding 0.56 to this. So when I do that, my final value would be minus 4.41912, and there you go. It is now moved forward. The final step for the robotic base is to now change the angle, because as we know, the robotic base was placed at an angle, right? And we measure the angle to be 17.26 degrees. I'm going to click on the rotate option. So I see this has to be rotated along the y axis to get this sort of rotation. So I can see this moving over here, right? And I'm going to change this to 17.26. There you go. Now we have it in place. So yeah, there you go. We are done with placing the robot base very accurately. Now we would move on to placing the puzzle on the table properly. Let us quickly look at how the puzzle is placed on the table. So we have two plates over here, and one plate is turned at a 45-degree angle and the other one's placed normally. And then the first plate is 0.638 meters away from the edge of the wall, which is also the edge of the table. Similarly, the second plate is 1.062 meters away. So now we have these measurements in our head. We would then try to mimic that in the Omniverse model. I'm going to first orient this plate in a 45-degree angle. So I'm gonna change the rotation to 45 over here. Okay. And then I want to set a pivot, which is here. So I'm just going to, yeah. So I want to set a pivot over here because I took all my measurements with reference to this particular point. I would click on my selection center, then go to my pivot tool. I already have added a pivot over here, so I'm just gonna change the dimensions accordingly. Okay, so this is good. After fixing my pivot, I would then move on to my snap tool. So I would click on the snap tool to activate it, check what all features are ticked. So I see my edge and my surface and my vertex are ticked, so that's good enough. So now I'm gonna move this over here. Perfect. Now this particular plate has snapped to that edge. So now let's work on translating this accordingly. I know that this plate is 0.638 meters away from the wall this way, and it is 9 centimeters away from the edge of this part of the table. I'm gonna go to my translate, and I know that it has to move um, 0.638 this way. So I'm going to add 0.638 to this measurement over here. That comes up to 0.77019, and I would have to add 9 centimeters to the x translation, and that would be minus 4.1581. Great. Now we have placed this particular plate precisely in the virtual environment. I would repeat the same process for this plate over here. I would first check where the pivot point is. I noticed that the pivot point over here is exactly where I want it to be, so I'm not going to be changing it. And now I'm going to work towards snapping this where I want it to be. Okay. Now that I've moved it over here, I'm gonna work on the translation. So I know I'm gonna be adding 1.062 meters to this particular Z value over here. So that would be 6.45169. Then I would be adding 13 centimeters to this value over here because I wanted to shift by 13 centimeters, and that would change the X value into minus 3.8156. Perfect. Now we have positioned this plate accurately too, and our final model to be positioned is the cube. So the cube sits quite well over here, but I'm just going to check if it's accurately positioned anyway. So in order to do that, I'm going to quickly run to the pivot tool, add a pivot, and make sure I have the pivot where I want it to be, which is right over here. And I see the snap tool is switched on, so I'm gonna like move and snap my cube here. There you go. Now the cube has exactly snapped, and it sits very well inside that indent on that plate. Okay, that's it. So we have finally finished positioning all the objects in a particular environment just as it is in real life. This method can be replicated for the other objects and models in the environment, and using this you can accurately recreate any physical environment in Omniverse. So now that you know how to use the snap and pivot tool, you can position objects exactly as they are in real life onto Omniverse. So I hope you liked the video, and thank you for watching.